All right, the goal for today is to get the bottom of this heat bed coated in this cork. We're going to do that by taking two of these squares, kind of cutting them up like so, making sure that they avoid these screw holes. So basically the biggest and most important one that we're going to avoid in the middle is here. Make sure it avoids this little thermistor guy right in the center here that controls the temperature. Don't want to smash that. And we're going to glue it all together using this wonderful high temp gasket maker. I have tried it with some of the lower temperature stuff, and I found that it falls off, especially once you start printing with ABS and some higher temp stuff. So I just go straight to the store, same stuff I use on my car whenever I work on it, and just slap her on, and it holds real good. So that's what we'll be working on. So it looks like I'm smarter than I thought I was. What we have here is that 12 inch by 12 inch. You can get this at your local Wally World, wherever the hell you want. But it looks like a 12 inch tile appears to cover the heated PCB portion of it pretty darn well. I mean, which makes sense from the stated build volume of this wonderful machine. But it appears that I'll only have to make a cutaway for the center portion here, and then make a cut for the portion that the first tile doesn't fill. So we'll get that cut away with a wonderful utility knife, and away we go. It looks like I recently got recalibrated my eyeball laser, because that joint don't look so bad, eh? Surprisingly, the laser eyeball has not let me down. That looks relatively in the right spot. Focus. Alright, that looks relatively in the same spot. So now we're going to apply a healthy dose of this mystery goop and see what happens. Alright, so now that we have the mystery goop applied and this pressed down, I'm going to go put this somewhere and put some weight on the cork just to make sure it settles and bonds correctly. This should be pretty set up for, in terms of 3D printing anyways, within probably half an hour or so, and the heat from the board will actually help it cure later down the line. I don't know if we'll be printing with this tonight or not, but should be good to go and ready to be reassembled with the plate that we're going to be sanding down next. So what's next on the list, now that the underside is drying with the cork addition, we have quite a few bumps of the super glue, more or less, that are sitting on the plate and are quite raised above the plate. So running across, you can definitely feel a huge bump. Try to get that in frame. But anyways, so we are going to be taking this down with first an 80 grit, and then we'll move on to a random sander and go down the different grades. So now I've taken it and I've knocked down all the high points, so there aren't any distinct bulges above it. So knock down those high points. So now we're going to get out the random sander and knock it down to about a 320 grit, and we'll do that over the entire surface, blending in these areas to make them uniform, and then we'll continue going up grits until we go to 4000, and that will eventually get everything nice and glassy smooth again for a wonderful printing surface. So now we've sanded them with a power sander, and now we're just going to clean it off with some rubbing alcohol, just to show the difference in between what originally started out as a very clearly marked up and scraped up one. When you clean it up already, just at 320 grit, is that the surface is already looking pretty darn glossy. So there's no real marks at all that you can see left from those original scratches. A lot of these are actually subsurface scratches. Smooth to the touch. Alright, so just finished my first round of wet sanding this guy with some 1200, and we'll work all the way up. Turns out I was wrong before. I only have a max of 1,000, 2,500, 3,000, not 4,000. So, oh well. I mean, it's smooth and bottoms come out like last time. So that's what we're gonna do this time. So I've made these small standoff posts that will not only raise up the base that the spring sees by a little bit, which will allow me to get a tighter spring, so I have a stiffer bed. So instead of flopping back and forth on the springs, I'm able to compress it less, which means it's easier to clear the the end stop sensor at the back there, which is actually pretty tight on these units. Compared to hitting the bed, so it's either you can't have it too high or too low, which is this is trying to solve. So I'll be able to have a stiffer spring, so it won't jump back and forth, but yet it won't be running into things there. But also, what I've done is I've made nut retention in the back, so I'm actually able to take just a regular M3 nut, stick it back there, and I won't have to worry again about losing the threads on that aluminum sheet like I had before, which started this whole deal. So hopefully this solves it. I printed this in just regular PLA since it won't see very much action, and this is actually a cold piece that sits below the actual heated bed. So now that we've sanded it off, there might be a little bit of clouds and it looks like there's some scratches, but this is smooth to the touch. I can't catch anything and I can't really feel any issues with the board. Actually, a lot of the scratches that you see are actually on the substrate, the aluminum material here. I did not originally ask for a aluminum plate because I was used to the RigidBot's original steel, or not steel, but original stamped, forgive me, stamped piece of aluminum, which tended to not be as flat as this nicely machined tool steel was. And so I actually originally was printing on a glass sheet on top of the PCB with no aluminum heat spreader. So I asked for just the PCB here, and I was going to have my own piece of glass, which is actually that piece of glass that you see there below was the original piece of glass that I was going to use. But I found that such a heavy plate of glass didn't really work very well, especially since this PCB is so large that it has all these screws around to hold it in place to keep it tight with such a large plate. So I eventually switched back to the aluminum plate and switched over to the PEI. So that's what I use today, and that's why we're resurfacing. Since we have our cork installed and it's nicely glued on with some very heat resistant engine rated yellow goop of the gasket maker variety. Interesting. Now we can begin reinstalling it. So all I'll have to do is just line it up with this plate, however the heck it goes together, screw in some screws, and then we'll be ready to put her on the bed. Alright, so now we're going to see if our wonderful new little add-ons here actually work. Oh, looks like this one isn't quite drawn in all the way. Top of the embedded nut in there is actually interfering with this edge, but yeah, it looks like I'll have to draw that one in with a screw, but it looks like the rest of them fit quite well as I clumsily drop. Alright, so I have the last one finally embedded, and we'll throw that in here. So, next step is to get this thing installed. So, we're just going to place it on top, try to seat the springs to balance them, and then we're going to run the screws down the middle. As I drop everything, I am a clumsy idiot. Hopefully the camera's getting something useful. If not, I'll move the position. All right. So now that we have the springs seated, we're going to try to put on the board and hopefully not break everything. But the problem is, the end stop doesn't hit, this side of it on the top here. It actually hits this side, so the far side from where I'm standing, on the bottom. So you need to have the bed clear the probe, which actually sticks above this bar that goes back and forth. And so that's kind of the hard mix between wanting a stiff, fairly damp bed and clearing the springs. If you tighten this all the way down and get quite a bit of tension on the springs, you can have a much more rigid bed compared to before. So I can hit this and it bounces some, but it comes back fairly quickly. Compared to a very loose bed, which will spring up and down and kind of float, kind of like an old Buick or something. Because I'm an idiot, these screws here are much shorter and they're lost forever now. Will be replaced by these, and I'm going to actually put on thread locker so that they will stay in there and not vibrate out like the issue that I was actually going to fix. Alright, so now that we've got that installed, we can go about our normal leveling process and then set up a mesh.